Okay, here's day 2, example 2. This is a popular question on the AP exam. And we have a 6-foot man walking toward a street light that's 18 feet high. And we want to know two things. At what rate is the tip of his shadow moving, and what rate is the shadow length changing? Okay, so here's a nice little diagram that's already been done for us. I want you to see that once again we have similar triangles. So I want you to see that there are two triangles. We have the bigger triangle, and we have the triangle made with the man and his shadow on the ground. Okay? So this bigger triangle, the measurements of this would be 18 and x plus s. X represents the distance between the man and the street pole. S is the shadow length, his shadow length. So S represents his shadow length. The smaller triangle would be made with the man and his shadow length. So, of course, we can do a similar triangle, and we can say that 18 is to x plus s as 6 is to s. So S is the shadow length. So what we're trying to find is ds dt. The man is walking 3 feet per second toward the shadow light, so that represents dx dt. That represents this distance he's going toward the shadow light. So we know that dx dt is equal to 3 feet per second. And we're trying to find dx dt. So we're going to use similar triangles to solve this. So I'm going to go ahead and cross multiply, and I get 18s is equal to 6x plus 6x plus s. Simplifying this, I get 18s is equal to 6x plus 6s. That's hard to say. And once again, simplifying, I get 12s is equal to 6x. Okay? Then we're going to take the derivative of both sides. So we have 12 ds dt is equal to 6 dx dt. And again, we're trying to solve for ds dt, so we have ds dt is equal to 1/2 dx dt, which gives us ds dt is equal to 1/2 times 3. So ds dt is equal to 3/2. And it's negative. And why is it negative? It's negative because dx dt is negative. Because he's walking towards the lamppost, because he's walking toward the origin, if we call this the origin, then it's negative. Okay? Because he's walking toward the origin, his velocity would be considered negative. So I should have listed this as negative 3s. So it would be negative 3/2 feet per second. Okay? So now we have ds dt, which answers actually the second part of this question. At what rate is the shadow length changing? Because this is the shadow length. The tip of the shadow is given by, is actually this entire length. So this entire length is the tip of the shadow, so it is x plus s. So the rate at which it's changing would be dx dt plus ds dt. And we know that dx dt is negative 3 feet per second, and ds dt is negative 3/2 feet per second. So the tip of the shadow would be negative 9/2. because I would make that 6 halves. Yeah, so that would be negative 9 feet per second. Okay? Alrighty, so that is example 2, and another example where we had to use shadowing. For example 3, I want you to see that example 3 is very similar to example 1. So what I would like for you to do is pause the video, and then I want you to do this on your own. And when you come back, pause the video, do this on your own, and then, well, actually, finish the video, complete this, and then I'll have the answer in the next video.